Okay, I don't know if there's anyone watching right now, but I thought I would just wait till I saw some, but there isn't. I had started trigonometry, grade 12 essential trigonometry yesterday. We talked about triangles, the different types of triangles, and I'm still on lesson 1. So we had done a lot of notes yesterday. So if you weren't here for yesterday's class, you might want to take a look at the note that I posted online. There's lots to know about triangles. So since I don't see anyone, what I think I might do, assignment 1 is quite big, and I don't have any feedback from anyone. So I'm not sure if I'm ready or if the class is ready. And by the indication I've been getting from some emails, I think there are people still a little behind in the class and just trying to catch up. So what I think I might do is just work through assignment 1 today. If you've already worked through it and you have no questions or problems, then I guess you've got kind of a bit of a day off and you can look at assignment 2. But what I think I'm going to do is I'm going to go through lesson 1 because it's an important assignment to understand the basics of trigonometry and triangles. And then tomorrow I'm going to study or start the law of sines. So hopefully everyone's okay with that. Like I say, if you got through assignment 1 and you have no questions, then you're ahead and you can take a little bit of break and enjoy the sunshine. All right, I'm on page 7 of the Trig unit. And one other note, if you didn't get into school to pick up the notebooks, I've posted all the PDFs of the books on the blog, on the little tab called book. You can just open that tab on the home page of the blog and then access the booklet you need. You don't have to print the booklet out. You can just, look through the booklet either when I'm doing the class and follow along and just make notes on a piece of paper. Or if you're lucky enough to be able to open it up on a tablet and you can write on the tablet, like use a stylus, that would be awesome too. But you don't have to print a booklet out. You can just write your notes on paper. So let's take a look at this triangle below. Fill the blanks with the appropriate letter for that side or angle. We learned yesterday that triangles, the corners are labeled with capital letters, and the length and the side lengths are labeled with lowercase. So if this is angle A, and that's the distance between these two arms of the triangle, 2 legs, then the side directly across from it is labeled as little a, lowercase a. If this is lowercase b, then the angle directly across from it is capital B. Similarly, if this is lowercase c, the angle across any triangle equals 180 degrees. So if I know two of the angle measures of a triangle, then I can find the third angle quite easily by just finding the difference between these two angles and 180 degrees, right? Every triangle equals 180. So if I start with 180, I know these three have to equal 180. And if I take away my 90 and my 35, that leaves me with 55 degrees left over. So theta equals 55 degrees. We learned about this symbol yesterday. This symbol looks like an O or a 0 with a horizontal bar through it. It represents an unknown angle measure, okay? And it is pronounced theta. It's a Greek alphabet letter. So that's what we'll use to represent an angle measure that we don't know yet. We'll be figuring out ways to solve for that, what that angle number is. And we've just learned one of the ways is three angles always add up to be 180 degrees in any, how big or how small. So if we just have one unknown angle measure, I could easily figure this out by just saying, well, they have to add up to 180, right? This plus this is 180. So if I just do a subtract. Now there's another way you can do this too, right? You could add these up and subtract from 180. Either way, we'll get the same answer. Process here, right? 180 minus 19 minus 75. And that gives me, 86 degrees. Now, angles, you can see they're not linear, right? Like if I wanted to measure the length of this side of a triangle, I mean, I would take a ruler, right? And I would measure it either in inches, centimeters, or inches, right? So we measure linear distances with a ruler or a yardstick or a tape measure. But angles, you can see, aren't measured that. The angle is the distance between this length and this length, right? So it's a curved measure. And we measure angles, curved spaces with degrees, right? So it's very important, that's 86, that I put the degree symbol on it, right? This one was interesting. We had a question like this in examples. If I have two thetas, if I use the same symbol, it means these have to be identical measures. So all I have to take away is my 40 degrees, right? So 180 take away 40 is 140. And if these are identical equal, I just divide by 2, and that gives me 70 degrees. It's the only way that the three angles would add up to 180. This was another new symbol that we learned when we have a box in a triangle. This box is the universal symbol to represent 90 degrees. Now, we could have written 90, but it's much more efficient to put the box. And it's such a common type of triangle, especially in the building trades and architecture and drafting, especially things like that. Any structure that we build is built at a 90 degree angle to the ground, right? The walls have to be sitting on the ground at 90 degrees. Otherwise, eventually the walls will kind of fold over on themselves. And then the building will fall apart. So if I know that this is 90 degrees, I take my 180, my total, I subtract the 90, I subtract the 45, and that actually leaves me with 45 degrees. So these angles end up being the same measure, 45, 45. We call that, when these two angles are equal, then I know that they're partner sides. Okay, this angle's side would be, partner side would be this one, and this angle partner side would be this one. And when I have two sides that have the same distance, like a triangle with two sides the same, it would be an isosceles triangle. Two sides the same as isosceles, three sides the same as equilateral. And then this last one, I take my 180, I take away the 88, I take away the 20. And that leaves me with 72 degrees. So theta equals 72 degrees. All right. So don't forget that. That's your first important formula for trigonometry. And it's all three angles of any triangle, no matter what size we have, equal 180 degrees. Okay. So let's see what the next page is. This was quite a lengthy assignment. It looks longer than it actually is because it's got lots of multiple choice, which always takes lots of room. And let's take a look at this one. Examine each of the triangles shown below. Hi, Cynthia. I noticed that too. We'll talk about that in a sec. Examine each of the triangles below. First, circle the correct name of that triangle if classified by side length. Then circle the correct name of the triangle if classified by angle. I made an announcement at the beginning of the stream that I'm going to just go over this assignment because I hadn't heard from anyone, and I know there's some people just trying to catch up. So I didn't want to go to the law of sines today too quickly. I'm going to review and go through every question in assignment 1. So if you're fine with assignment 1, then you have the day off, I guess. Otherwise, I would just want to make sure everyone's got the foundational skills for trigonometry. So I'm going to go through all the questions for assignment 1 so that it can be on record too. Examine each of the triangles below. Circle the name of that triangle. So it says circle the name of the triangle if classified by side length. So circle the correct classified by side length, and then circle classified by angle measure, right? So first I take a look at this. There's 4 triangles to classify. I look at this triangle. If I classified by side length, is this equilateral? No, they're not all the same length. Is it isosceles? No. So it must be scalene. And if all the sides are different lengths, all the angle measures have to be different lengths. Okay. So that means that's not a choice though, not a scalene angle choice. So is it a right, an acute, and obtuse? Well, I see this corner here with 90-degree angle, so it's a right triangle. This triangle, let's see, I've got 2 sides the same, but not 3 sides. So that means it's an isosceles triangle. And right, acute, obtuse, it's got to be obtuse because one of the angles is greater than 90 degrees, right? This triangle, all sides different, so it's scalene. All angles are different sizes, but they're all less than 90 degrees. So it's an acute. And this one, all sides the same. So that means all sides the same, all angles, it's an equilateral, and all angles are the same too. And we know that every equilateral triangle, no matter how long the sides are, they have to be 60 degrees because that's the only way I'll get my 180 if they have to be all the same size. And if they're all 60, 60, 60, that means they're all acute angles, so it's an acute triangle. Okay. Number 4. Unity's building roof trusses as shown. So this is kind of an odd-shaped roof. Answer the questions shown below the diagram. Circle the answer that the triangle above. Okay, so here's the triangle. I have scalene, right, for sure. Okay, it's scalene because all sides are different lengths. Okay. It's not equilateral. It's not isosceles. I don't know if it's a right triangle though. Let's see. Let's find this missing angle. 180 minus 23 minus 67. Okay. It is a 90-degree triangle, right? So they actually could have put a corner here. Is this the right triangle? What do you tell her? Justify using math, which I just did. Okay, so yes, it's a right triangle. The missing or unknown angle is 90 degrees. Okay. And my work is shown up here, right? Just put an arrow there. Okay. Choose the letter that best completes the statement below. An isosceles triangle must have, okay, what's an isosceles triangle again? Remember what that is? An isosceles triangle is two sides the same, right? An isosceles triangle must have a right angle. No, that's not true. Two sides the same length. Yes. All angles, different measures. No, if I have two sides that are the same length, two angles are the same as well, and they all acute. No, not necessarily. I could have an obtuse angle, an obtuse isosceles. So let's try this one. Choose the letter that best completes the statement below. The triangle pictured at right is scalene. No. I've got two sides the same, right? Two sides are the same. Two sides are equal. That tells me it's isosceles, right? It's not equilateral. It's not a right triangle. And it's not scaling. So it's an isosceles again. Okay. All right, let's take a look at these last two questions, Cynthia. And I don't know who else is watching. I think someone else is. So that's nice. Welcome. Bill is building rafters to go on a house. He asks you what the measure of the angle labeled theta needs to be in the diagram shown below. Note that the rafters are of equal length. So rafter, this is a rafter too, right? It might not be clear, but that's a rafter. This is this is taken from a technical manual. And I know that they're equal length because they have the hash marks here, okay? Determine the size of angle theta. Well, if it's an isosceles triangle, that theta has to be 38 degrees, right? 38 degrees, that's what these two are the same measure. Explain to Bill how you determine the size of angle theta. The angle must be equal to 38 degrees because it's an isosceles triangle. If two sides are the same, or if two sides are equal, their corresponding angles are also equal. Okay, sorry, I kind of went off the page here, okay? Okay, and then the last question. So this did go quite quickly. It seemed like there were lots of questions, but they just took a lot of space. Lavini has constructed a small pyramid out of playing cards as shown below. Determine the size of angle A, so that's this angle, and determine the size of length A. Okay, well, knowing that it's an equilateral triangle, that should help us out a lot, right? If it's an equilateral triangle, if I know that this distance is, and it's an equilateral triangle because length of playing card, and this is a triangle, so it's equilateral, so everything's equilateral, right? This whole pyramid, they all have to be the same distances. So that means that if they're equilateral triangles, then that means that all angles are the same length. And for equilateral triangles, that means angles are the same length. So angle A must be 60 degrees, right? And I could just put this here, equilateral triangles have 60-degree angles. All the angles have to be the same size if all the sides are the same length. And that means they can only be 60 degrees. Determine the length of side A. Well, if each side of each triangle is 3.5, I'll have 3.5 inches and another 3.5 inches. That little double quote mark means inches. So 3.5 plus 3.5 equals 7 inches. Okay, so that's how long side A has to be. So again, it looked like it was going to be maybe take more time. I initially thought it was going to take us longer. So we're done. I'm done going through assignment A, and I feel good. Hopefully everyone can have some closure on the foundational stuff for trig. I guess what we could do is we could start with the law of sines. It's a kind of a big topic in a way. So maybe what I'll do is I'll start with the law of sines, and I'm just going to start with finding side lengths, okay? So I'm going to break up your assignment a little bit. So I've got the sine law. And let's just refresh how to label triangles. So angles are labeled with capital letters. So this capital A refers to the size of this angle. Capital B refers to the size of this angle, and capital C, this angle. Now, A's partner is this side, B's partner is this side, and C's partner is this side. That was important to know in lesson 1, but it becomes crucial to know in this next part of the course. There is a relationship between the angles and the sides opposite them. So that's really important. This relationship is called the law of sines. Okay, so that's really important to know. That's why they partner up like that. And the interesting thing to know is that the length of side A divided by sine of A. And now this is the same sign that we saw in our sine, cos, and tan formulas in grade 11. But these are a different set of formulas. So how triangles work, this length divided by sine, and sine is something you find in your calculator, sine angle A, is exactly equal to this length divided by sine of his angle, and it's equal to this length divided by sine C. Now, in a math question involving law of sines, we only ever use 2 out of the 3 ratios, right? Because we only do math equations with 1 equal sign. So we'll either be dealing with these 2 sides or with these 2 sides and angles, or with A and C. So we'll never ever use all 3 ratios at once. We're just going to use 2 at a time. So note the letters in the numerator top represent sides, the denominators represent angles. We knew that already. And then although this relationship exists for all 3 pairs, we only use 2 in each question. All right, how does this law of sines help us out? Now, remember that we had the sine, cos, and tan formula from last year in grade 11 or last course. Those were only able to be used for right angle triangles, for triangles with 90 degrees. So I just want to maybe put a little note up here. We must use the law of sines for triangles, without a 90-degree angle. Okay, maybe I'll add something top here. We use sine, cos, and tan, right? Remember these guys? Equals op over hypotenuse, adjacent over hypotenuse, and op over adjacent. We use these guys for 90-degree triangles, right triangles. So that hasn't changed. If we had a 90-degree triangle, we'd still use these guys. If we don't have a 90-degree triangle, we have to use something else, and that's why we use the law of sines. Okay, so we can see this triangle here. Okay, if I was going to find the missing side, or the missing angle, let me just double check this. 180, take away 43, take away 62. Yeah, this is 75. It's not a right angle triangle, so we can't use law of sines or SOHCAHTOA. So now you're asked to find missing side x. So how the law of signs works is you look for a complete partnership. So here, when I say complete partnership, these guys are partners, and these guys are partners, right? Now, this is what I call a complete partnership, meaning I know both of the numbers. There's nothing unknown. So I know 26 and I know 43. In this partnership, one of my members is unknown, and that's why we're using the law of signs to solve for this unknown. So what do? I take this side length, my 26, and it sits on top of sine of 43. Okay, that's really important. Remember what the formula says? Side over sine of the angle. This sine is really, really important because 43 degrees doesn't mean anything to your calculator unless you have the word sine in front of it. All right, here's my unknown. X sits on top of, well, his partner is sine of 62 degrees. Okay, so we have a cross multiply situation. We've seen this before. In a cross multiply situation, when I want to find what the unknown is, now I've done this a few times in class, but I'm just gonna, how I figure out the unknown is I multiply when I cross my numbers like this, right? I'm cross multiplying. So the two numbers that I can match on my cross multiply get multiplied together. 26 times sine 62, 62 degrees. And the member of my cross multiply without a partner gets divided out. He doesn't have a partner, he gets divided out. Okay? And that will give me my answer to x. So I take my calculator, and you need a scientific calculator. Now, just get your little scientific calculator, and I don't know if you can see, but make sure that you're in degree mode, just like you did in grade 11, right? Make sure it says DEG. Now, I don't know if you can see this. It's pretty bright in here today, but if you see on my screen, it says DEG for degrees. So you got to make sure you're in degree mode. So 26 times sine 62 divided by sine 43. And that gives me 33.66. And what were side lengths measured at? Feet. Okay. So that's my answer. And that's how I found out what x is. Now you can see law of signs, the procedure is always going to involve cross multiply because I have a fraction equaling another fraction. And the technique that we use when we have fraction equal fraction and there's a number unknown is the cross multiply method. So I'll just wait and see if there are any questions. It looks like there's a couple more people watching. No questions? All right, let's try another one then. Okay. Determine the length of the side labeled x. Okay, here's my x. Let's see. I have partnerships again, right? Partnerships. So I'm going to set up my complete partnership first. 46 sits on top of sine of 73 degrees. My unknown x sits on top of sine 77. Okay. Now remember, law of signs only works partnership. Okay. Sorry, so my calculator calculates the sign before the number. Cynthia, can you type in what kind of calculator you're using, what the brand name is? If it's a Texas Instrument or a Casio. I think I might have to tell you another way to do it. If you have, what you might have to do, if you have a calculator where you can't see what you're typing in on the screen, Cassie, okay. See what you're typing in on the screen, then you're going to have to do this, Cynthia, or anyone else who has a calculator that doesn't seem to be giving them a right answer. Okay, so I'm just going to flip back for a sec. So if your calculator doesn't type in like this, then you're going to have to type in x equals 26 times. I think all you have to do in that case, Cynthia, is just switch your degree and your sign. So you're going to type in 62 sine divided by 43 sine. So try that. I call it a backwards calculator, and they just work a little differently. See if that gives you an answer of 33.66. And I'll just wait for you. I got the right answer only after doing all that, then pressing the equal button. It shows answers before. Yeah. Okay. So I'll add the equal sign in here too. Okay. Thanks, Cynthia. Yeah. So you'll have to just type your degree in first, and then press the equal sign. Okay. Everyone's calculators, usually when I teach this in a normal class, I usually spend the first, 10, 15 minutes of a trig class just walking around and checking everyone's calculators, because every calculator works a little bit differently. And that's the number one thing is you have to know. But however you used your calculator, if you're using the same one from grade 11, it works the same way. Okay, so x equals, right, I'm solving for x. So let's see the numbers that, if I cross multiplied like this, okay, these are the numbers, right? This is my guy without a partner, right? The guy crossing with x is the guy that you divide out. So 46 times sine 77. Okay, for Cynthia, you're going to go 77 sine, right? Divided by sine 73. And, okay, 46 times sine 77 divided by sine 73 equals 46.87, if I'm rounding to 2 decimals, meters. Okay. Just wait for everyone to catch up there. We've got 2 more examples to do, and then I'm stopping for today, and I'll tell you why after we finish this. I'm breaking this lesson up into 2 parts. Okay, no questions. We have a few people watching. I'll keep going. I'm going to do these last 2, and let's see what this one is. Determine the length of side x. Okay, here's side x. Let me get my partnerships going. I have a complete partnership, right? These guys, complete partnership. And then this, though, x, I have to solve for x, right? That means I have to use x as partner, which is unknown, right? So any idea of how this is a slightly more challenging question, right? Which is why it came a little later. I can't use this angle measure because he's not x's partner, right? X's partner is unknown. But if you remember, we have that 180 rule we could use, right? I could figure out what theta is. If I just take 180, take away 80 degrees, and take away the 29 degrees. And that's going to give me 71 degrees. So theta equals 71 degrees. Okay. Now I have the angle that I must use for x. You can't just use any random degree, right? You have to use partners. So these two are partners. And x's partner is the 71. It's not the 80 degrees. So let's set this up. 52 sits on top of sine 29. X sits on top of sine 71. Okay, so remember the drill here. I multiply these two and I divide by the leftover, the guy without a partner. X equals 52 times sine 71 divided by sine 29. Okay. And I get 101.41 centimeters. Okay. So that was a bit interesting, right? Even though it looked at a glance that, oh, they gave you all the right info, just like they did the last time, you know, a side, an x, and two angles, it wasn't the right angle given that we could use. So we had to employ the 180 rule in order to find the missing theta. I'll wait, no other questions? Okay. And then lastly, this is the last example, and then I'm going to give you a couple questions to work on. Let's see. Once again, okay, x's partner is the 120, right? This one's harder to see. And then the 9, the angle across from the 9, this is kind of interesting. 31's partner side is this one, which is blank, but the 9's partner is theta again. So this is another one of those tricky ones, right? I have to find the third angle. We actually we don't use the 31 in a formula. We just use the 31 in the 180 rule, right? So because 31's partner is nothing special. It's not where x is. It's not where my side length is. So what's theta going to be? Well, let's see. Theta is going to be 180, take away 120, 31. So 29 degrees. Theta equals 29 degrees. Okay, that was the missing angle that I was looking for. So I have 9 inches, partners with sine of 29. And my mystery number, x, partners with sine of 120. Okay, so same thing as always. Multiply, divide. So x equals 9 times sine 120 divided by sine 29. Okay. Okay, and I get 16.08 inches. And that's it. That's it for today. So we worked through all of lesson 1. So all the answers are at the beginning of this video, today's video. And then we worked through the first part of the lesson 2 on law of sines. I'm going to tell you what I'm going to assign you for homework. So we're going to leave these as examples till tomorrow, because it's kind of, law of sines is not difficult, but there's a little bit more to it than just a day lesson. So all I'm assigning you for homework is Assignment 2, number 1, A to E. You can see those are all the questions with X's on them, right? X, 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 X. And these ones are thetas, right? So these we'll do tomorrow, solving for theta, solving for an angle. So I just want you to work on assignment 1, A to E, okay? All right, that's it. I will. Hi, Nicole. I'll have to say hi to Jerome later. I will stay online if there are no questions for the day. Remember, as soon as we finish this, it takes me about a minute or so. I'll just upload it to the blog. Then you can rewatch it when you have time. And I will look forward to seeing and chatting with you all tomorrow. Remember, I also posted something new on the blog today. Every day at 10 o'clock, I have a resource period, just like I did in school. Like at 10 to 11 every day, I was in the library for extra math help. So if you want, you can meet me tomorrow in a Google Meet room. So I'll just be waiting at my desk at home, waiting to see if anyone wants to pop in and meet me in the Google Meet room tomorrow. Like every school day from 10 to 11, I'll just be there. If you have any questions about math, about homework, or any other, about math or school in general, you can pop in and meet me tomorrow at 10 o'clock. So hopefully I'll see someone there. If there are no other math questions then, I guess I'll end the stream and I'll upload my notes and post the video on the blog. And I guess that's it for today, everyone. So thanks for joining, and I will talk to you tomorrow. Okay, you too, Nicole.